Welcome to the AMATIC 2014 webinar series, The Common Core in the Community College with Ted Coe, and this presentation is sponsored by the Teacher Preparation Committee of AMATIC. AMATIC is the American Mathematical Association of two-year colleges, and our core value is building expertise and exhibiting leadership in the teaching and learning of mathematics, enhancing personal growth, and improving teaching methods and effectiveness is a personally initiated lifelong responsibility. And for more information, please visit our website at amatic.org. And please note that the views expressed by the presenter are not necessarily the views of AMATIC, and any commercial products mentioned by presenters are not endorsed by AMATIC. And now we're going to switch to TED slides. And I'm going to put the share up here on the screen, Ted, so that you can share your screen. And let's turn over to Ted. So if you want to welcome Ted in the chat room, that would be great. So
all right. Thank you. Can you guys see my screen now? Yeah? Okay. Okay. All right. And my monitor, my extra monitor is acting a little buggy, but hopefully the comments will be working, so I'll be able to see what's going on around. Hey, I am so excited at this opportunity to jump in and talk about some of the passion that I've developed for the Common Core over the past 3 years or so, particularly because I spent a good chunk of my career working in the community colleges. So I started out teaching high school over 20 years ago before moving into the community college system. And I worked in the Maricopa Community College District. I had the chance to be the chair at Rio Salado College and the chair at Scottsdale Community College before I left about a year ago to go pursue being an assistant dean for University College of Education at Grand Canyon University. Then just last month, I made the transition to a job here in Washington, D.C., working with the group Achieve, where I'm serving as the director of mathematics. So I feel like a kid in a candy store here, where I get to deal with all these issues about the mathematics that I know that I and all of you share the same passions for. So let's talk a little bit here. I like to look back on the 20 years of teaching that I had and reflect on what is good teaching and learning when it comes to mathematics. And I like to try to sum it up in 3 tiny little statements, 3 easy to remember statements. And the first statement is that mathematics as ways of doing. And this is pretty common. We all see mathematics as ways of doing. Our culture sees mathematics as ways of doing. But I also see that there's parts to what we do as mathematics professors and teachers that focus on mathematics as ways of thinking and mathematics as habits of thinking. Now, let me walk you through this little three-part framework. For instance, with the ways of doing, one of the things I ask teachers to reflect on is that mathematics is more than doing. What is the value added that the math teacher brings to the classroom that says goes in excess of say the Khan Academy. So the Khan Academy does a fantastic job at what it does, and that is that it shows people how to do math. In other words, somebody says, I don't remember how to do something, they can watch the video, they can see how to do it. And the same kind of discussion happens when the students might end up in my classroom at the community college years down the road, where they would say something like, when we got to a math piece that they didn't understand, what did they say? They would say, I don't remember how to do this. And additionally, what happens along this line of thinking, if mathematics is just about ways of doing, is I ask people to reflect on, so when you got done with your mathematics experience, whatever walk of life you're in right now, did the mathematics that you walked away with feel like somebody had just given you an unfinished puzzle with 1,000 pieces and it's just in a cardboard box and it's shaking around? Or was it more like you were looking down on the table at that completed puzzle? And I think most people are going to say, well, no, it was really about those pieces, I just had a random collection of pieces. And we reward those. Our tests, our placements, our assessments, these kinds of things reward mathematics as ways of doing. So what I want to do, though, is I want to walk you through this idea of ways of thinking. And so I want to use a little activity as a device to get you to see what I'm thinking when I talk about developing ways of thinking, and I want to try to challenge you to maybe pick up a pencil or something like that, because I'm going to ask you to do a little bit of mathematics. And usually I'm in a room where I get to interact directly and see the looks on people's faces when we go through this. But I'm just going to have to trust you and watch for your comments as we're going through it. So here's the world I want you to imagine, that the universe consists only of 3 broomsticks. The first broomstick is 3 feet long, and it's red. The second the yellow broomstick is 4 feet long, and you have a green broomstick that is 6 feet long. That's it. That's the universe. That's all we got. And I want you to focus on these 3 things for just a moment, and I'm going to ask you this question. All right? How much longer is the green broomstick than the red broomstick? All right? And I think most of you have an answer. I'm not seeing any comments come on, but I'm sure that most of you have the answer. Now, the issue here, and some of you are picking up on it, is that I asked an ambiguous question, because a lot of people are going to answer this question in terms of 3 feet. And they're going to say 3 feet. Yeah, I saw that pop up. So some are going to say the answer is 3 feet. Some people are going to say twice as long. And this is a really, really important distinction, because what we're talking about is 3 and 2, and they both are describing the same situation, but obviously the quantity 3 and the quantity 2 are not the same quantities. Now, what's the difference here? Well, on the left, I'm talking about additive, and on the right, I'm talking about multiplicative. And we know that math ed researchers will tell us that our minds really drift easily to the additive, but we have a harder time with the multiplicative. And I know from experience that when I backtrack through curriculum, you'll see much more thinking additively than you will multiplicatively. Now, now you understand where I'm going with this. You got the additive on the left and you got the multiplicative on the right. So what I'm going to do now is I'm going to ask you a second question. How much longer is the yellow broomstick than the red broomstick? And I want you to give me the additive answer on the left, and I want you to give me the multiplicative answer on the right. I'll give you a second to think about that. I'll even help you out. There you go. So now whether or not you got an answer, my question that I take to any group that I'm working on this with is, was the mathematical cognitive demand on the left any different than the mathematical cognitive demand on the right? And pretty much universally, people will say, well, it required more cognitive load from me to fill in the box on the right, because the multiplicative was harder. And if I can put this in a room full of teachers, and I'll get probably at least 4 different answers to this question. But the point being that, yes, there was more of a load on the right, I'm anticipating, than there was on the left. And my claim is that there shouldn't be. There shouldn't be. So I like to walk people through a little bit of an example. All right, and here's how I might build this up. So I'd say, let's consider that we have the green broomstick. All right, and the yellow broomstick. And my question to you is, and I'm now removing that ambiguity, I'm just talking about times as long as. I'm removing the additive world. I'm forcing you into the multiplicative world. And I want to ask you to compare the green broomstick to the yellow broomstick. Well, what are we going to look at? We have to attend to certain pieces of this. Now, what I've highlighted for you is 1/4 of yellow. I hope you can see that. On my monitor, it seems to be going a little more slowly. Can you guys see the 1/4 of yellow that I circled? Yes, okay, great. All right, so I've got the 1/4 of the yellow, and then I want you to think about, well, I want you to compare the length of the green to that 1/4 of the yellow. And I would see that I have 6 copies of 1/4 of yellow, which means I have 6 copies of 1/4, or 6/4. Now, some people are going to say that that's an improper fraction, or that I need to reduce that fraction. But what I'm going to say is, I want to leave that here for a second, because both the 6 and the 4 as quantities in this context had meaning for me. If I were to rewrite this as a proper or mixed number or reduced or whatever you want to say, then I'm going to lose the track of those quantities. So hang on for just a second. But what happens now if I were to flip it around? I'd have the yellow measured in terms of the green. Well, I'm going to do the same thing. I'm going to say that I'm highlighting 1/6 of the green. The yellow is 4 copies of 1/6 of the green, which means I have 4 times 1/6, or 4/6. Great. And some people at this point start to go, well, interesting. So the answer to the one was 6/4 and the answer to the other was 4/6. Huh. Well, let's keep on going. If I were to go down and do the yellow against the red, I'm going to see that the yellow is 4 copies of 1/3 of the red, or 4/3. So the yellow broomstick is 4/3 times as long as the red. And similarly, the red would be 3/4 times as long as the yellow. So the punchline here is to notice that the answer to the question on the previous slide is the 4/3. But we didn't have a way of thinking about it. But what I want to point out is that we have an understanding of the operation of division showing up here. And that is that the operation of division serves as a multiplicative comparison. So if I need to compare two numbers additively, all I have to do is subtract them. If I want to compare two numbers multiplicatively, all I have to do is divide them. Now, it seems like that's a real simple observation, but what I found in practice is that that particular way of thinking about division just isn't really at the forefront of most people's minds. But it turns out to be a very, very powerful way of thinking about division. So for instance, I ask this question. Say a stock starts at $74, and a year later it's valued at $89.54. By what percent did the stock's value increase? Well, you could choose to look at this as though it's a percentage question. Say, oh, I remember how to do percentage questions. There was a formula I'm supposed to fill in and a procedure I'm supposed to follow. Or somebody could come along and say, well, all I need to do is find out the multiplicative comparison of these two numbers. And that is to set something up like this. Now, when I write the 8954, it has meaning. When I write the 74, it has meaning. And when I put that division there, the division has meaning because it's going to tell me how many copies of 74 are in 89.54. And once I've established that, I can then interpret my answer in terms of percentages. So we get 1.21. Well, what is the 1.21? Well, I got the 1 is 1 copy of, and the 0.21 is 21 hundredths of, so I've got a 21% growth. When I've used this with community college faculty in the past, this is where eyes kind of light up and start to go, wow, this would make my teaching of exponential functions significantly easier if this kind of understanding had been built into the thinking of students early on, because we spend so much time trying to work with those factors and which way do I put them, and you guys all know what I'm talking about there. All right, so the ways of thinking. Let me now show you what encouraged me about Common Core, and that is that the Common Core is built on these what they call the progressions. All right, you can follow an idea as an idea grows from one idea to another idea to another idea to another idea, and it's really kind of cool because what I'm going to do is I'm going to show you, for instance, down in 3rd grade, we've got a 3NF1. The standard says understand a fraction 1 over b is the quantity formed by one part when a whole is partitioned into b equal parts. Understand a fraction a over b as the quantity formed by a parts of size 1 over b. So what I'm doing with that activity I just showed you is I'm building off of this understanding of fractions, setting up an understanding for this type of fraction. And this is where fractions start in the Common Core. Now, let's look at multiplication. In 3rd grade, interpret products of whole numbers. So we would say 5 times 7 as 5 groups of 7 objects. And this is a common, obviously a very common model for multiplication. What really starts to shine, though, is when I look at what happens in 4th grade. And I'm going to highlight some phrases here. Because in 4th grade, we see in the first standard here, interpret a multiplication equation as a comparison. In other words, start thinking of multiplication from that comparison perspective that I was just walking you through with the broomsticks. The second standard you can see down there has that language at the end. 4th grade, distinguishing multiplicative comparison from additive comparison. So we're starting to lay the foundation very early here. In 5th grade, we see that the multiplication is extended to the notion of scaling. So we got another model here that we're looking at. Multiplication is scaling, comparing the size of a product to the size of one factor without having to perform the indicated multiplication. This paragraph comes from a document called Learning Trajectories in Mathematics. The head author was Phil Darrow, one of the key authors on the Common Core. And Phil, they make this claim: in grades 6 and 7, rate, proportional relationships, and linearity build upon the scalar extension of multiplication. Students who engage in with these concepts with the unextended version of multiplication, that is like that third grade version, will have prior knowledge that does not support the required mathematical coherences. If we don't build up this thinking about multiplication along this progression, then the students are going to be left in a bad spot. Now, this puts a lot of pressure on those 5th, 6th, 7th grade teachers because they have to understand where their mathematics lies along this progression, and they have to make sure that they don't resort to just teaching quick little tricks rather than actually getting at the mathematics. So let me give you an example. What do we mean when we talk about measurement? This is something that I do a lot. I've done a lot of work with in trying to have teachers change just a slight perspective on what they're thinking here. So a common book that we might use in our teacher prep programs for pre-service teachers, the Van der Waal book, this is from 2001, says technically a measurement is a number that indicates a comparison between the attribute of an object being measured and the same attribute of a given unit of measure. But my question here is, well, what does he mean by comparison? Because we now know that there are multiple types of comparison out there. We've got additive comparisons and we have multiplicative comparisons. Well, I think a whole lot of good happens when you start to think about measurement in terms of multiplicative comparisons. How many copies of one thing is there in another thing? How many times as large is one thing compared to another thing? So I like to talk about measurement from this perspective. First, we're going to determine the attribute you want to measure. I want to measure length. Okay, great. I spot that I want to measure length. I have to find something else with length, and I'm going to use it as the measuring unit. And then I'm going to compare the two multiplicatively. How many copies of one is in the other? Now, the question would be, well, what if I were to switch the thing being measured and the unit of measure? Well, what we saw back in that broomstick activity is all that would happen is I'd have the reciprocal response because I'm just comparing two numbers multiplicatively. So measurement becomes simplified. This comes from my dissertation advisor, Pat Thompson. He says, you know, we can move from thinking about 12 little lengths called inches to the total length of this is 12 times as large as the length of that. So that's a number of things versus a ratio or a multiplicative comparison. So what else does it buy us? Well, it buys us quite a bit. As I showed you a minute ago, percentage. Percentage becomes much more simplified, and likewise as do exponential functions. I love how I could have students walk into my calculus class at the community college and ask them, what's the circumference of a circle, and start getting just sort of random formulas, because they're not really thinking about what the formula for the circumference of a circle is doing, and it's really a measurement. So for instance, if I were to think about this, c divided by d, but I think about it multiplicatively, not just in terms of a formula, I'm asking how many diameters, how many copies of the diameter will it take to go into the circumference? And we know that regardless of the size of the circle, that it's going to be 3 and a bit. And my little diagram there off to the side shows you that regardless of the radius of the circle. Similarly, the other form of this that says c equals pi times d says, well, what do I want to know? I want to know if I want to measure the circumference, I can measure the circumference in terms of diameter lengths. I'm going to use a diameter length as the standard unit of measure, and it's going to take 3 and a bit of those. So we can track this kind of thinking throughout geometry, particularly geometry and the formulas, and make sense of the formulas multiplicatively. Certainly, pi r squared is with the area works the same way. Similar figures become really, really important in the progression in the Common Core as we move up to geometry. So suppose I tell you that you have two similar figures here. Well, what I want you to do is I want you to focus on that 2 and that 3, and I want you to just imagine for a second that those are two broomsticks. All right, and I want you to give me the multiplicative comparison of those two broomsticks. It's the corresponding distance 2 to 3. Well, depending on which way I draw that arrow, I could have a comparison of 3 halves or a comparison of 2/3. Well, I drew the arrow this way, so I'm going to have a scale factor, if you will, of 3 halves. So what do I need to do to find the corresponding length for this side of length 5? Well, all I have to do is apply that same scale factor to it. So it's the extension that's grounded in that very, very simplistic thing that we started off seeing in the understanding of fractions in grade 3, and then the additive versus multiplicative in grade 4, and progressing on up. Now, this becomes really important to us. For instance, maybe we don't usually make this connection, but if I were to consider a linear function, you know, what makes a function linear? And it's this notion that we have these similar triangles, And no matter how I set up these similar triangles and adjust the points on them, I can see the multiplicative comparisons down below, and I've outlined them for you, and that that red length is always 1/2 of the blue length, no matter how I adjust this. So I have this notion of a linear function being based in something other than a definition of y equals mx plus b. It's based on the notion of what's happening with these similar triangles. And this shows up actually clear down in grade 8 in the Common Core. Use similar triangles to explain why the slope m is the same between any two distinct points on a non-vertical line in the coordinate plane. Derive the equation y equals mx for a line through the origin, and the equation y equals mx plus b for a line intercepting the vertical axis at b. Grounded in the similar triangles, which is grounded in all of that multiplicative thinking that started from the very beginning that I know people have a hard time with. But it's simple enough that we need to teach it. Where does it go from here? Well, you can find all kinds of places it goes, but one in particular is this notion. Let's assume that angle A is a right angle for a second. And some of you are probably, hopefully, looking at the triangles that I'm showing you right now, and you notice that, well, I know what kind of triangle that has to be then. I mean, it has to be a right triangle, but more specifically, I can see that red length, when measured in terms of the blue length, is 1/2. So this triangle has to be a 30-degree triangle. It's a 30, 60, 90 triangle. But what I'm also evidencing in a diagram like this is showing that as I scale, right, as I scale these triangles with C as my center, then it does that multiplicative comparison never changes. That opposite, measured in terms of the hypotenuse, is always 1/2. And so we've seen this thing track now from 4th grade all the way up through high school. Here we go. Defining trigonometric ratios. That understand that by similarity, side ratios and right triangles are properties of the angles in the triangle, leading to definitions of trigonometric ratios for acute angles. What I did with a group of middle school teachers not long ago was in a project I'm doing with Scottsdale Community College, is we took them along through this progression, but we did it over the course of a year. We did a lot of exploring along the way. But when we got to the point where that middle school curriculum sort of ended with respect to this progression, I was able to move them into trigonometry, and point out to them that, guys, when you follow this, understand that your students are 5 minutes away from trigonometry. That because of the way these ideas have been built up, the right triangle trigonometry is just right there waiting to happen. Right there. We don't have to come out the gate saying, hey guys, now just imagine there's a right triangle, memorize these formulas, and go from here. It can be grounded in the thinking that was built up all the way through. So that's an example of ways of thinking that I would talk about. That's a progression that I've worked through in the Common Core. So my ways of doing in the classroom need to come out of the ways of thinking. And the ways of thinking are a value added that the teacher can bring to a classroom that something like Khan Academy never can. And I point out to teachers, I'll say, hey, if all you're doing is doing what Khan can do, there's a good argument to be made that Khan is doing it better because Khan's got millions of dollars behind it. I can pause and rewind Khan. I can see it in different colors. All of these kinds of things are out there, and I want to make sure that as math professionals that we're focusing on the fact that we bring much more to the table than anything that a computer can bring, and that is that we can help develop these ways of thinking. And we know our students, and we can start to work on these progressions and making sure that we're consistent with them. Well, so if my ways of doing has to come out of my ways of thinking, the third point that I had was also on habits of thinking, and that I want to be able to start to build in the minds of my students good habits. Now, what was really interesting is about 3 years ago, through a higher ed engagement outreach, I was at the community college, and Park came along and asked a bunch of us from around the country, what would it mean to be college and career ready? So I busted out the Common Core for the first time. I was going to go address this question for them, and they wanted to use Common Core as obviously the guiding document. So I said, well, okay, I'm going to read this. And when I read it, at the very first few pages, we end up with these notions of the 8 standards for mathematical practice. And these are going to play a key role in where I'm going to walk to in just a second. But what caught me off guard is when I got to these mathematical practices, the take became kind of like, wow, if we could really do this, and then have a collection of those key practice, those key standards that are in the rest of the document, then wow, where could we take our students? If my students walked in with the ability to make sense of problems and persevere in solving them, if they could reason abstractly and quantitatively, construct viable arguments, critique the reasoning of others, model with mathematics, use the mathematics that we're teaching, use appropriate tools strategically, attend to precision, look for and make use of structure, look for and express regularity in repeated reasoning. So these things are outstanding. And these are places for us as math professionals to focus. How do we build up these kinds of things in our students? And now that's what I'm calling the habits of thinking. And obviously, in national terms, the national discussion is more around the mathematical practices. But I see them as extremely valuable. We have these put onto posters for the teachers in our workshops so that they can take them back and put them in the classrooms. You could even turn around and have the students grade you and say, all right, what did I hit today in the lesson? Did we use appropriate tools strategically, attend to precision? We can begin to model these things in our classrooms. Well, now the tricky part is assessment. So we have all of this coming down the pipeline, but we have to build in, we have to assess these things somehow. How do we start to assess ways of doing, ways of thinking, and habits of thinking? Well, so one thing I want to point out, and this comes from that Darrow article again, is that one mistake that we've commonly made in the past is that we read individual standards as individual ingredients of a test. The explicit goal really is to have the ingredients cook into a cake, so tasting the uncooked ingredients is a poor measure of how the cake tastes. The goal, as stated in the grade level introductions and the practice standards, is for the students to cook. We want the students to be like a chef, to be able to cook, to put this together and to make something out of it. But our assessment has tended to be focused on one little tiny bite at a time. They got the right amount of salt, they got the right amount of pepper, and so we end up kind of focusing our assessment back on just that way of doing that first part. So as an example, I pulled these the other day off of one of the Arizona Department of Education websites. They have since been pulled because Ames is no longer in Arizona with the transition to the Common Core. So, but here's an example of a typical multiple choice question, and you look at it and you go, yeah, okay, that seems to be doing the work for me. It's basic and it gets to it. But funny things happen when you start to try to do things that are a little more grand in the world of multiple choice. And you might end up with something that looks like this. And wow, it's just hard to even argue through this question, at least from my perspective, because they ask which problem is best solved by using the same strategy. That requires me to climb into the test writer's mind, I think, try to figure out first what do they mean by strategy, which strategy, and how are they defining best. So this is a really tricky question. This one I thought was kind of interesting. We've got a nice grade 6 geometry question here where they're asking you, where should you put the fourth point in order to build a rectangle? Now, I don't know if you guys see this, but I found this to be a particularly challenging question because that angle turned out to be around 96 degrees. So I had a hard time with it. I'm sure other people have as well. But here's one in particular, and this gets at the notion of when we're talking about assessment, and particularly as we prepare teachers for creating assessments farther down the road, is we're looking for evidence of something. We don't just want to throw a question up there because it looks like a good question or it's a classic question or it's something we've done. The question is, what does this thing do? What evidence will it show? And so sort of the classic example here is, what is the value of x? The standard that they're getting at was solving radical equations that involved one square root. And I would claim that you could get the right answer to this without having to really solve that equation involving only one square root. You could pretty much just plug in the values and substitute. So it really just becomes can you substitute a value in and do some computations and see if they equal 15. So the idea is that our assessments have to be doing lifting up quite a bit more than what we've typically seen in the past. And we need the evidence, but we also need to be hitting something broader than just ways of doing. So what's going on in the world of next generation assessments? Well, there's two large multi-state consortia right now, Smarter Balanced and PARC, and the odds are good that your state is in one of the two. I come out of Arizona, and so I've been very involved in PARC. PARC, I was just up until about a month ago, I was serving on their math operational working group, so I had the chance of seeing the day-to-day progression of the mathematics and as it was being developed towards this assessment. And I learned a whole lot in the process. Fantastic professional development. Well, real quick, so Smarter Balance is going to make an overall claim for grade 11 that students can demonstrate college and career readiness in mathematics. So could we get this to a point where a student could walk into, let's say, a non-remedial credit-bearing math class and succeed? Could this test pull that off? That would be a goal. There's some subclaims in here, and this is what's sort of interesting, because I'm going to contrast this with Park over the next couple of minutes. The smarter balanced claims, they're going to be working on assessing these things: concepts and procedures, problem solving, communicating reasoning, and modeling and data analysis. So they're going to be moving their assessment into these zones, if you will. They're going to be able to make claims about students being able to communicate their reasoning, which means they're going to have to assess that. So this is their subclaim structure. On the Park side, Park is making the same overall claim. They're on track or ready for college and careers. Park is going to say that if you get a sufficient score on the Park exam, that would mean that you could walk into and succeed in a credit-bearing entry-level college algebra or introductory statistics course. So they have 5 subclaims. The first is that the students solve problems with major content, and then solve problems with additional and supporting content. And that's defined in another place, but it's basically the standards have all been parsed out into either subclaim A or subclaim B. Some are major, some are supporting and additional. It goes back to the Common Core and the notion of focus, putting the focus where we need to put the focus and not treating every single mathematical topic or skill as equal. Subclaim C, students express mathematical reasoning by constructing mathematical arguments and critiques. Park is going to make a claim about students being able to express mathematical reasoning. Park is also going to be able to make a claim about students solving real-world problems that involve modeling. And in grades 3 through 6, they're going to make a claim about fluency. We hear a lot, maybe in newspaper articles and things, about a lack of emphasis on fluency, but that's not the case with the Common Core, nor is the ignoring of standard algorithms. So what do you see here? If you look back at the overlap between the Park and the Smarter Balanced, what you're going to notice is that both of them have pulled out these 2 practices as targets, which is pretty cool because those are pretty 2 big practices. That to construct viable arguments and critique the understanding of others, and to model with mathematics, you're going to cover pretty much all of these practices along the way as well. But assessments are moving in this direction of being able to get at these things beyond just doing the skills. Park, just is a quick framework for you. They've broken this down into 3 different types of tasks on their assessment. So they have type 1 tasks, which are concepts, skills, and procedures, and these could be machine scorable. They have type 2 tasks, which have to do with expressing mathematical reasoning, and you can see that targets mathematical practice 3 and mathematical practice 6, which was precision. They have type 3 tasks, which call for modeling. So they are going to have tasks that get at problem solving, they're going to have tasks that get at reasoning and argument, and they're going to have tasks that get at modeling and application. And these things can contain integration of standards along the way. So it's a big deal. Here's a sample item. These are on the Park website, and these are what they've released in the last few months. As an example, Mr. Edmonds shared 12 pencils among his 4 sons as followed, and you can kind of I don't have the time for you to spend a whole lot of time on this, but notice down here in part A, it's talking about on the number line represent the fraction, and you can click more tick marks or fewer tick marks and interact with this. Part B then says what fraction of the total number of pencils did Carl and David each receive? Justify your answer. And so there's going to be a rubric alongside this that talks about how to interpret the kinds of responses that students would possibly come up with in justifying their answer. Now my question to you before I hit the next slide is I want you to just take a second and guess what grade do you think that would be. All right, you got it? You got it? Okay, you don't have to type it in. I'm just asking. This is a grade 5. And this would be a type 3 task. It has to do with getting at modeling. I'll give you another example. Ava and Mia are comparing the fractions 3/2 and 5/6. Ava did this, Mia did that, and you need to select the correct point on the number line to represent those fractions. Part B says, is 3/2 greater or less than 5/6? Explain how you know. Part C, write a fraction between 3/2 and 5/6 and explain how you know. All right? And so I'd say, okay, what grade do you think this is? Got it? Take a guess? 4th grade. And that's a type 2 because we're really getting at the reasoning and argument in there. Here we go with a, I lost the grade level on this one. Kelvin is a 100-meter race at an average speed, v meters per second. He completed the race in 12.5 seconds. He used the drop down to complete the equation. What was Kelvin's average running speed? This would be a type 1, 2-point, 6th grade item. And I'm tossing this out to show some of the complexity that some of these tasks can get to. Local mini golf courses charges $5 per person to play a round of golf, and the course sells 120 rounds of golf per week. And we go on and we have the table shows the price, the number of rounds of golf. Part A, based on the data, write a linear function to model the price of 1 round of golf. Based on the data, write a linear function to model the number of rounds of golf sold in a week in terms of the number of 25-cent increases. Part B, based on the data, write a quadratic function for the weekly revenue in the week, R of n, in terms of the number of increases. And use your quadratic function to determine the weekly revenue in a week when tickets cost $6.25. The maximum, part C, the maximum possible weekly revenue is what % greater than the weekly revenue with no price increases? Justify your answer graphically or algebraically. I'd love it if my college algebra students would have been able to pull off this question in good form. Just to put this in perspective, this is now targeted at the Algebra 1 level, this sort of thing. This is a type 3 task focusing on modeling, as we mentioned before. Just to make sure that we don't think that all these things are this complex, we do have lower complexity tasks as well. Complete the subtraction problem by typing the answer in the box. So you can do this. This is a type 1 question. It's worth 1 point. So we see that the assessment is going to be changing. Students are going to be used to a higher level of assessment, and in my own practice, I think going back and experiencing what's happening here has started to change the way I think about how I would like to do things in a classroom, and making sure that the assessments that I use, that the tasks are providing evidence of something and not just tasks that I want to throw on there because I've always used them, but what will they really be telling me? Now, the other aspect of this that's sort of interesting is that there are a lot of materials being developed across many states. University of Arizona is doing a nice job with this. Bill McCollum is really known as one of the key authors, if not the key author, on the Common Core documents for mathematics, and he's down at U of A. And he's got a project down there where they're building the progressions documents for these, where you can grab one of these and you can start to follow through the ideas, because in the I just lost my monitor. Okay, in the K5 progression for measurement and data, you might be able to download that document and you'll be able to see how those ideas travel across the grades rather than how those ideas are sitting within a grade as come straight out of the package with the Common Core. So they're taking the Common Core and they're reworking it and they're putting it in this perspective. When I was working with Maricopa a little more than a year ago on redesigning their developmental math program, and we were making great progress, and they're still making great progress on it, I brought these documents to the table. So as they were thinking about redesigning developmental mathematics, they could see how the progressions of ideas were going to be developed in the Common Core in a way different than how we would normally do it with particularly the developmental level. So we have a nice sets of materials. Other things that are out there are actual curriculum, and different groups are putting out different curriculum, and a lot of them are releasing them under Creative Commons licenses. So you'll see New York State Common Core. This is from I just Engage New York. You can go to their website and download these things. And you'll see very, very well thought out lessons. Now, they may not be perfect yet, but because they're open, you could take them, you could modify them, and you could use them. So you have resources here. Down here at the bottom, you can see, if you're not familiar with that little logo down there, that little logo is a blessing to educators. That's the Creative Commons license. And so when you see that, it means that you can do certain things. Creative Commons, if you just see a CC BY, that means that you can use these materials, and you can do whatever you want to them, but you have to reference the original author. You have to give credit to them. If you see an NC, that means, well, an extra layer on here is that you cannot use this for commercial profit. If you see an SA on there, it means, and if you do use it, you have to share it alike. So when I see these Common Core materials from Engage New York, I know that I could take them, I could adapt them for the community college. I could then reference to say, hey, I got these from the Engage New York, and as long as I'm sharing alike, I'm putting the same license back on these materials, and I'm not charging for these materials, then I'm within the bounds. I can run all the photocopies I want, and you make the improvements on it, and the next group comes along and does that. And we were doing this sort of thing at Scottsdale, where we were grabbing a lot of the open materials, and eventually, but when I left a year ago, we were at the place where we had all of our courses, with the exception of college mathematics up through pre-calculus, we're all using open materials that anybody could now go to the website and download for free. So workbooks and text-based materials and all of these sorts of things. Because these kinds of materials are out there, and with the advantage of the Common Core, people are working in the same direction, so there's a common language as we start to mess around with these materials. Something that comes out of my group that I'm doing here at Achieve is the Equip rubric. And what we do with this is to help us, help users, I should say, try to determine whether or not the curriculum that they're looking at is good curriculum, in the sense that it aligns to the Common Core. We know that there's a lot of talk out there right now. You see a lot of examples about things that are being blasted on wherever in the news and the newspapers, on websites, where people are saying, look at this example of Common Core. Well, we know that there is no official licensing body for Common Core. Anybody can come along and put a sticker on it and say, yeah, this is Common Core. But we can add something like a rubric to this process, where we talk about, okay, if we think this thing's aligned to Common Core, let's run it past this filter, and let's see how it does. Now, what kind of shocks me is that when I see how good this is, I realize that a lot of the things that I've built over all of my years teaching wouldn't fare so well, particularly in column 3, where we talk about instructional supports, because we tend to build the materials for us to use. Well, what would it take to be able to build the materials for other people to use? Is this notion of the instructional supports, and then also with the talk that we had earlier about assessment, making sure that our assessments are of a very high quality, and do the kind of work and provide the kind of evidence that we hope them to provide. So, wow, you guys just got a sip out of a fire hose with regards to Common Core. I'm not seeing any questions popping up. So let me tell you what where I see the community college impact in a big way. One of the I'm sure it's the same in your world, but in my old world, placement was just absolutely a difficult thing to grapple with. And so one of the interesting aspects of what we're seeing with Common Core, particularly with the Park and the Smarter Balance, is the possibility of having placement assisted by using these extra instruments. This could be a very good thing in the grand scheme. You know, for now the focus is on college algebra and the introductory statistics. But that's a tough one. That's a tough one. Well, I could go on that one, but I won't. All right. And looking at assessment, are the kinds of assessments that the community college faculty are bringing to the students, are they going to be of the same caliber of the assessments that they're going to be used to soon to be coming out of the K-12 system? Will they, if we use the Park framework, will they be? Are we offering them the opportunities to work not just with type 1 questions, but with type 2 and type 3 tasks as well? Are we giving them the opportunity to reason an argument, to look at their own reasoning, to critique the reasoning of others, to such a degree that we could assess them on that? And are we bringing the mathematics to life enough that they could actually use the mathematics to apply and model and go forth and see the value in the mathematics that they're doing? Content. So as I was pointing out with respect to the content, there's a whole world of common languaged content that's being developed around Common Core, and it's being done in such a way that a lot of it is under those Creative Commons licenses, and the community colleges can easily grab parts of that and run with it and use it and make it better and turn around and share it. And the opportunities are huge there, because there is so much overlap, particularly with that sort of those first lower level classes in the community college curriculum with what's happening in K-12. Instruction. along with these shifts that we're seeing with the focusing on the reasoning and the argument and on the modeling, the students will probably become used to a different kind of instruction that they might see in K-12. Will the instruction in the community college follow along the way where students have the chance to practice reasoning and argument and practice modeling and those other mathematical practices along the way? So will the instruction at the community college change? And then finally, I know this is the group about pre-service. There's a lot I think that pre-service teachers can take with and run here. We are at a place where new ideas about the teaching and learning of mathematics are coming out in a grand scale, and they're coming out with very nice licenses and the ability for us to share ideas and to almost have a, using the Common Core as a common language with which to talk about the mathematics. So the pre-service folks have a lot to think about with regards to getting teachers prepared for that K-12 world that they're going to walk into, that probably is going to look a whole lot different than the world that we came out of. So I got done here. I think I got about 10 minutes left. And there's my contact information. I live in Arizona, but I work in Washington, D.C. at this point. So sometimes if you can't catch me, it's because I'm in a plane flying across the country. But I enjoyed this. Let's go to questions. All right, Alexis is saying, sounds great. Is there a listing of sources for the materials mentioned for activities and assessment? The answer is there are lots of listings and there are lots of repositories, and the trick is to find the best ones and go with them. There are different groups that are doing reviews on these things. I know that the state of Washington just recently ran a number of open curricula through multiple frameworks, including the EQUIP framework, to find out if they were good materials or not. There are some really interesting creative activities, say with a group called the Mathematics Vision Project. That's in I think Utah. I like some of the materials I'm seeing there. CK12 is starting to move in the right direction. We adapted a lot of their materials at Scottsdale. And then up in Washington State, with regards to their community college system, they've actually been working through a large grant to develop open educational materials, not necessarily aligned to Common Core, but they have a great deal of materials. So David Lippman up there, we were using a number of his books as well as his homework system. So Alexis, I hope that answers your question. John says, I know that Common Core policies are sometimes specific from state to state. The Common Core, I like to say I like to focus on the math side. The policy that might affect math would be that states that adopted Common Core could add up to 15% additional standards to it. So in Arizona, you're going to see, for instance, some discrete mathematics standards that were appended to the Common Core document. But otherwise, the policies would be more on the political side, not the math side. Ruth. NCTM was attacked when they came out with their standards, but they prevailed. A growing group of parents and teachers sadly are organizing through opt-out groups. Yes, I've heard. And I wonder what we should be doing as teachers to make the other side of the Common Core available. And where are we on state involvement in adoption? Well, there's a lot there. One of the things that I do is I try to keep. For me, I like to have my three-pronged points, and that is that the mathematics is not just about doing things, but it's about thinking about things, and it's about building those habits. And if we can come up with some examples, maybe grab even some of the things that I shared with you here, you could run with that as well. As far as state involvement in adoption, that's something that Achieve, the group that I'm with right now, we like to see that. We like to see the states involved. So maybe we can talk outside, and we can get some ideas specific to Pennsylvania. You got my email address right there. Amy Curry, you can search for free materials at creativecommons.org. You can, absolutely. And you can learn about the Creative Commons licenses there too. You can also go to a place called OER Commons. OER Commons uses an Achieve rubric to help filter through the kinds of materials that are available there. Why do I think there is such a backlash against Common Core in states like Texas? Oh boy. Oh boy. I there are lots of reasons, but the you know you hear a lot about the local control issue. Um, the there so the states want to have a control over the standards as different states are debating having the standards in their state or not. I kind of look at that and go, well, if you can walk away from these standards at any time, then you have control over it. So let me leave that there, Kathleen. That's a very big question, and I could go on for quite a while with it. Pam, was implementing Common Core one grade at a time ever under consideration? That I that I can't speak to. I know that different states have been trying different implementation paths. New York went pretty quickly through it, and you can follow up and see how that went. Kentucky also. So yeah, you certainly read different opinions on that implementation process and timeline. Pam Cox, new math way back in the 60s. If the parents do not understand what their children are doing, you can expect backlash. That's true. An interesting comment on the new math. I was doing a meeting the other day, and the room had a bunch of mathematicians in it, and one of the mathematicians said, "Oh, I just heard this is just the new math all over again." And so I actually pulled out my copy of well, I said, "No, I think you're wrong," and I pulled out the Common Core itself, the document, and I set it in front of him. And it took him about 3 minutes of flipping through it to realize this is not new math. This is math. So I see a few others are typing. We'll wait a second for those to come up. The backlash I was referring to was content, not to local control. So okay, all right. So I was thinking about one of those common political issues I hear about with respect to the content. It's interesting. My challenge I think would be to really go back to the document itself, the Common Core document, and make that the point of the conversation. All right, if you're gonna say this is new math, well, here's the document. Here it is, and tell me what you think is new math. If you think it's missing certain standards, or if something's out of order, here tell me. I mean, show me and walk it through. The nice thing about this is that when it comes to the Common Core, we have the document. It's not mysterious. It's not hidden, and it's usable. We can all get it out and read it, and we can see specifically what's in there. So I challenge people to look at the Common Core standards themselves. You're very welcome. So Brianna, I know that the talk in Arizona was about, yeah, if you're going with the park test, then that park test could serve as placement into college algebra or that introductory statistics. Uh, if a student wanted a placement other than that, then you would end up back with the existing placement process. There's and also Brianna, there's talk about, and I'm not sure where the line is being drawn, but there's talk about what's the expiration date. I think I saw on an SBAC document just a few minutes ago of about a year. Oh, you're welcome, Heidi.
Okay, well, I hate to cut off all of the good questions, but we only have about 2 minutes left, so I want to make sure that everyone gets the link for the survey. So thanks again to everyone for participating in today's AMATIC webinar. And if you'd like to support future AMATIC webinars, please consider becoming a member of AMATIC at bit.ly/join-AMATIC. And please remember to like us on Facebook at facebook.com/AMATIC. And recordings of past AMATIC webinars can be found at bit.ly/AMATIC-webinars. And it typically takes us 1 to 2 weeks to produce and upload webinars to this archive. And if you could please take 2 minutes to evaluate the webinar content and the presenter today at bit.ly/AMATIC22, that would be great. You can actually click on the link on your screen right now as well. And if you need email confirmation of your participation in this webinar, please fill in the optional section at the end of the evaluation. And again, all of that goes through me, so it's actually as fast as I get to it. So I really appreciate all of you who do fill out the surveys. And again, if you could thank Ted in the chat room, that would be great. And I hope that all of you have a great